Okay, we want to finish 4.2. We're starting here with objective C, so this is still part of 4.2. We're talking about the number E. Number E. So E is Euler's number. That's why it's an E. It is a number. It is like pi. It's irrational. So you have to represent it with a symbol or round it. So this is the approximation for E, 2.71. This stuff here, the beginning, is the definition. You don't have to memorize that, but that's where it comes from. So as x goes to positive infinity, so the bigger and bigger numbers you plug in for x, the closer and closer you get to this number here, 2.71 approximately. So you have an e to the x button on your calculator. Okay, it's by ln, by the natural log. So we're just going to evaluate some of these. We'll graph in just a minute, but for now, we just want to evaluate. Let's just round to the nearest hundredth place, so 2 decimal places. On your phone, if you're using your phone, that you have an e to the x button. If you have an iPhone, just turn it sideways. You'll need to put the exponent in first and then hit e to the x. But regular calculators, you have an e to the x, you'll press that and plug in the exponent. So if we round to 2 decimal places, we should get 7.39. Okay, e to the 0. Well, anything to the 0 power is 1. Exactly 1. So go ahead and do these last two. So you should have gotten 0.04 and 1.65. Everybody able to get those values? Okay. All right, so let's look at the graph then. All right, I want to graph this function. I'm going to add a little negative right here, so it's e to the negative x plus 2. So transformations means we want to graph the parent function first. So the parent function, remember parent functions of exponential functions, is just the base to the exponent. My base here is e, so e to the x. So I'll make a table for e to the x. We have some of these already evaluated for us. So let's do at least one negative, so negative 1 and then 0. And I just did 1 and 2. Okay, so if I round to two decimal places, because you have to round here, since e is irrational, I have 0.37. E to the 0 is 1. E to the first is 2.71. And e squared was 7.39. Okay? So I'll go ahead and graph those. It still has a horizontal asymptote at y equals 0. Okay. So I'll just plot the points and then use the transformation. So the parent function looks just like any other exponential parent function, like y to the 2x, y to the 4x. So y equals e to the x looks similar. So e is just a number. Now the only difference is like your points that you're plotting, you have to approximate because e is irrational. But if I now do the graph of f of x equals e to the negative x plus 2, I'm going to use transformation. So the negative x means I reflect up over y. Remember the negative up here for the x, you reflect over y. The negative out front reflects over x. And then the plus 2 at the end, I shift up 2. Good. So let's move the asymptote first. So if you reflect your asymptote over the y, does it change? No. If you shift it up 2, does it change? If you move a horizontal line up 2, does it change? Yes. Okay. Now I'm going to take all of these points and reflect over y and shift them up 2. Okay, so graph, and then make sure you label. After you graph, go ahead and fill out your domain and range. So what's my domain? Good. Reals. Negative infinity to positive infinity. And what's my range? Good. 2 to positive infinity. Parentheses on the 2. Questions about that? Okay, so we will use e more. Okay. Right now, what you need to think of it is it's just a number. E is a number like pi. Okay. So when we go to this next objective here, D, we are going to start solving exponential equations. And then we will also look at an application. So So to solve exponential equations for now, we want to use this uniqueness property. Now in the next section, we'll start talking about logs. So we'll solve using logs as well. But for right now, we want to use the uniqueness property. So what this says is if I can get a single term on the left and a single term on the right, and they're the same base, then all I have to do is set the exponents equal to each other. Well, that makes sense, right? Because if you have 4 squared equals 4 to what? Well, to get those equal, this right one has to be 2. Yeah. To get the same value, the exponents would have to be the same. Okay? So that's what we're going to use. So I'm going to start off with some examples here. Okay, looking at this, you probably can figure out what the answer is without doing any work. So what should x be? What does my exponent need to be? 2. Okay, so that's pretty straightforward. If it's that easy, you can just write 2. But I am going to show you how we use uniqueness property because we'll need it for the problems that we're going to do in just a minute. Okay, so I have 2 bases. I have 144 and I have 12. So the first thing I want to do is start with the smaller one. I want to write things in terms of the smaller base. It's much easier to do that than try to go from the smaller to bigger. So the smaller one is 12. Is there a way I can write 144 as base 12? Can I rewrite 144 so it has a base of 12? Yes, it would be 12 to what power? Yep. So I can rewrite that as 12 squared. Okay. Then the uniqueness property tells me once you have common bases, you just set the exponents equal to each other. So you can think of it like those bases canceling, and you just get then 2 equals x. Okay. So start by looking at the 2 bases. So ignore the exponents for now. Start by looking at the 2 bases. You have 9 and 27. Okay, what's the smaller one? 9. Okay. Can you write 27 as base 9? No. Okay. So what's another number that you kind of associate with 9 and 27? Okay, let's see. Can you write 27 as base 3? Can you write 9 as base 3? Okay, so that's what we want to do. So we're going to rewrite as base 3. So this is 3 to the 3rd. And then 9 is 3 to what power? 2nd. Okay? So it's 3 squared, but then I still have this x minus 1 out here. So I just wrote 9 as 3 squared. Okay. These are single terms, even though you have stuff here, that's okay. The exponent doesn't matter. You want the common base. So then you can cancel the 3's. And you have 2 times x minus 1. So you have to be careful and make sure you distribute that 2 and then equals 3 on the right. So now we're just solving this equation. 2x minus 2 equals 3. So 2x equals 5. X equals 5 halves. So you can plug it back in to check. Make sure that works. But these are the type of problems that will be on your no calculator part of your quiz. Okay? These will be on the no calculator part. So you have to understand this first step, how to write them as a different base. That's the hardest part. Okay, just the first step is the tricky part. Okay. So these problems are listed if you're looking for other ones to practice. This is in 4.2. Okay, so start with the bases. So what's the base on the left? What's the base on the right? 1 over 32. Okay, well the 1 over, what does that mean with an exponent? Negative. So I'm going to ignore that part for right now. I know I'm going to have to use a negative because it's 1 over, but really what I'm focusing on is the 32. So I'm focusing on the 2 and the 32. The bigger one is 32, so I want to write it in terms of base 2. So I want to write it in terms of the smaller one. Can you write 32 as base 2? You can. You can write 32 as base 2. So 2 to the 5th is 32. But remember, it is 1 over. So I have to use negative 5. Because I want the 1 over, I have to use negative 5. Alright, so I don't have to change anything on the left, because that's already base 2. On the right, I'm writing 1 over 32 as 2 to the negative 5th. So that 2 to the negative 5th equals 1 over 32. I'm not changing the values at all. I'm just rewriting. Okay. So now that you have a common base, you can cancel and set the exponents equal to each other. Make sure you remember to distribute your negative 5. Oh, yes, thank you. Okay, distribute negative 5. Add 5x to both sides. And divide by 3. Okay, if this is on the no calculator part, then you don't expect to get really weird answers. All right, now you could do some fractions, but they're not going to be complicated. Like 5 halves, okay, you can deal with that. 2/3, you could deal with that kind of fraction. But if you did something like, I don't know, 16 over 7, you probably did something wrong. Okay? We're going to practice more when we're done today. Okay, so we'll practice more of these when we're done. So I'm still wanting to do the same thing here. I'll let you write it down, and we'll kind of talk about it first. So I get single terms on the left and right. Okay, so knowing that, what do you think I could do here on the right, or the left, I'm sorry, the left. You have parentheses and a number out front. Yeah, let's distribute. Okay. So I'm doing e to the x times e to the x. So I'm multiplying a common base. So think about properties of exponents. If you multiply a common base, then you do what with the exponents? Add. Okay? So x plus x is 2x. Okay? And then that has a 1. So plus. So e, and then x plus 1 is just x plus 1. Okay? So think about that for a second if you're not convinced. You need to write it out like this. Okay, when you multiply a common base, add exponents. All right, well, the next side on the right, so that's all I can do right now. I can't combine these because you're adding in between. So there's not a way to combine those because we're adding in between. So let me move on to the right side. All right, well, what I know I can do here is I can separate and make 2 terms here. I can go ahead and separate those. So I'll write both of them over e to the negative x. All right, I'm bringing back rules of exponents again. When I divide a common base, I do what with the exponents? Subtract. So x minus negative x. 2x. Okay? So I'm going to make a note. Okay? And then 3x minus negative x. 4x. Okay. Well, I still have 2 terms on the left and 2 terms on the right, but I only want 1 term on each side. I notice I have a common term, e to the 2x. So if you subtracted both sides by e to the 2x, those would cancel. So these whole things cancel, not just the base, the whole thing. Now I have what I want. Now I can use uniqueness property because it's 1 term on the left, 1 term on the right, and they are the same base. So my goal, that was my goal, to get to this. Because now I know, okay, I can cancel the base and just set the exponents equal to each other. So 1 equals 3x. So x equals 1/3. So my goal was to get to here to use uniqueness property. Okay. Questions about that? Okay. We're going to look at a word problem, and then we'll stop with notes and do some practice problems. So take a minute to read. So part A, how much is this copier worth after 1 year? So we're going to put 1 year. You're going to plug that in for T. If it costs 64,000 new, so we're going to put 64,000. And yep, B sub 0. So, okay. That means that I don't know V of T, but I have all this. So when I have everything filled in on one side, you're just plugging it in your calculator. And I put in 64,000 because it didn't tell me that it was given to me in thousands. So I had to put the whole thing here. If it had said originally in thousands, you would have only had to put 64. Okay, so I get $40,000. Good. Okay. It's a word problem and it's money, so if you had to round, you should round to 2 decimal places. We didn't have to round here, though. Okay, part B. How many years does it take for the copier to depreciate to a value of 25,000? So where am I putting 25,000? Yes, via T. So 25,000 goes here. We're assuming it still costs the same amount, so 64,000. And what I don't know is T. Okay, so I want to use uniqueness property, which means I need a common base. What is the base of my exponent T? What's the base of T? 5/8. Okay, so I want this on one side by itself. So let's go ahead and divide by 64,000 on both sides. 5/8 is a fraction. So I want to make sure and I keep this left side a fraction. You can reduce it. It might make it a little bit easier if you reduce. So it should just reduce to 25/64. So the smaller numbers are the 5 and the 8, so that's what I want to compare. Can I write 25/64 in terms of 5/8? Yes. What exponent would I raise 5/8 to get 25/64? 2. So remember, when you have a fraction to an exponent, you're exponentiating top and bottom. So they're the same. So 2 equals T. Okay. So 2 years. That is what I would expect you to do. Just run a quiz. I would expect you to do that. Okay. Guess and check could get you there, but that's not how you should solve it. All right. If you want full points, you need to solve it algebraically, not guess and check. Any questions about this? All right, so that's where we'll stop with notes. We will do logs tomorrow. So we could solve this using logs as well.